Welcome to MedSci-Hub catch-up lessons where we deal with question papers. Right now we are going to look at grade 12, paper 1, 2016, question 2 and 3, which is number patterns. Before we go into the question paper, I'm just going to quickly go through some of the equations that are based on number patterns. And you know you have two types of number patterns, which are arithmetic or linear number patterns or geometric number patterns. Can be called geometric or exponential number patterns, but the most common name is geometric number patterns. So these are the two sections that are based on question 1 and question 2 of your question paper. Now, arithmetic number patterns, you know you have this condition where your T1 minus T2 minus T1 equals T3 minus T2, right? Meaning if you have a pattern or a series of numbers and you minus your term 1 and term 2, it should be equal to your term 3 minus your term 2. Now, this is called your constant difference. Now, the formula used for arithmetic number patterns is Tn equals A plus open bracket n minus 1 times D, where your D is called your common difference, and then your A is called the first term, and the last equation in arithmetic number patterns is the sum formula, which is Sn equals n over 2 bracket 2a plus open bracket n minus 1 close bracket D. Sorry guys. Now this is the sum formula. These are the two formulas which are based on linear number patterns. Now looking at geometric number patterns, it is normally denoted or described as T3 over T2 divided by T2 over T1. And looking at the different formulae, we have the first one, which is Tn equals A times R all to the power of n minus 1, and then the sum formula for geometric, it's Sn A equals A open bracket R to the power of n minus 1 close bracket all over R minus 1. Now remember guys, these formulas are always given in your sheet, so you don't have to memorize these formulas, but then you should know when to apply them and which formula applies for which question. So it's very important to distinguish between different formulas and be able to apply them differently. Now the last part that we are going to look at is, before we go to the question paper, is convergent geometric number pattern. Now before I do that, let me quickly write down or explain what each of the variables mean. You know your A is your first term, and then we call your R, it's your constant ratio. And guys, whenever a question says a sum or adding or a total, what should come to mind is the type of formula that you are going to use, right? Either in geometric or in linear number patterns. Whenever there's a sum or adding or putting together or a total of anything, whenever there's a sum or they say put together or they say all together, what you should understand from that statement in your question is they are putting together, and what you should be knowing is that in that case what should be applying is your sum formula, right? Now the last thing that we are going to look at is the convergent geometric number pattern, right? Which is denoted by your constant ratio in a geometric number pattern should be less than 1, but again greater than -1, and then your constant ratio should not equal 0, right? And whenever you do this, you know your sum to infinity equals 1 over 1. Your sum to infinity equals A over 1 minus R. So these are the formulas that you are going to use whenever you do number patterns. So I just gave a brief or just wrote down all of those formulas, and let's see how we apply them. And like I said, we are going to look at question 3 and 4 of June 2016 paper 1. Alright, let's see what the first question says. So let's look at question 2.1, which says given the arithmetic series A plus 13 plus B plus 27 plus ... goes on and on and on. Now the question says 2.1.1. So it says show that A equals 6 and then B equals 20. right? Now we are going to do what? Write the formula, or what we know in terms of arithmetic sequence, right? And we know T3 minus T2 equals T2 minus T1, right? So let's go ahead and determine those, and then we can clearly see 27 minus B equals B minus 13, right? Now from here we can see that we can write our B on one side, and then if we take the B to the other side, and then we take the minus 13 to the other side, we will have 2B equals 27 minus 13, minus 13, which is 14. Now actually, if we take the 13 to the other side, the sign changes. So it's going to be plus, which is 40, right? And then we divide by 2. Your B will equal 20. Now we've determined the value in our pattern for B, which is 20. We know our B is 20. Now we need to find what A is, right? Again, we say 13, minus A, T2 minus T1 equals T3 minus T2, which is, now remember we found our value for B, which is 20, so we can simply say 20 minus 13. So from here we take the 13, cross it over, and then we have minus A equals 20 minus 13 minus 13, 20 minus 13 minus 13, which would be 13 minus 13 minus 13 minus 13 is minus 26, plus 20 should give you 6, negative 6. And remember, we are looking for A, so we can simply divide by a negative, meaning your A will equal 6. Your A should equal 6. Your A should equal 6. Now we've determined the value for A and B. Our A is 6. Now from here, so that your job can be easy, guys, you can immediately from those unknown variables, you can immediately try to determine your first difference, right? Because we are dealing with arithmetic sequence. So from there, try to determine your first difference, because you don't know what the second question is. But then, for the sake of determining all the values, we just determine that your A is 6 in that pattern, and then we have 13, plus we determine the B, which is 20, plus 27, plus ... Now from here, get your first difference, right? let's say 13 minus 6, which is 7. 20 minus 13, it's 7. So here should be 27. And then 27 minus 20 is 7, right? Now from here, let's go to the next question. It says calculate the sum of first 20 terms of the series. First 20 terms of the series. Now we're dealing with an arithmetic sequence, arithmetic pattern. So your equation in this case is Sn equals n over 2 open bracket 2a plus open bracket n minus 1 close bracket times d, right? Now the question is clear. You are looking for the sum of the first 20 terms, meaning this is what? This is your n, right? What are you looking for? You are looking for S20, right? So let's go on. Sorry, we know our n is what? Our n is 20 over 2, right? And then 2 into a, right? The a, don't be confused, the a is what? Your first term plus n 20 minus 1, and then the common difference, as we know, is what? It is 7. So from here, sorry, let me just write the value for a. I just said it's 6, right? From here you can just use your calculator. This is 12, and then it's 19 times 7, 19 times 7, it's 133, 133 plus 12, it's 145. Remember, we still have this. I just worked out what is in the bracket. So 20 divided by 2, it's 10 times 145. 10 times 145 is 1450. So the sum of the first 20 terms in this series is 1450. That's question 2.1.2. We are going to look at 2.1.3, which says write the series in question 2.1.2 in sigma notation. Now guys, what you need to determine there first is determine your equation in, remember this equation, these patterns, they are in what? Arithmetic or linear pattern. It's an arithmetic and linear pattern. And our formula, as you know, is Tn a plus open bracket n minus 1 plus d, and we've determined your first term plus n minus 1, close bracket, and then our common difference there is 7, right? So let's try to simplify this first, which is, if you simplify it and we distribute the 7 to the 1 and to the n, to the negative 1 to the n, we have 6 plus 7n minus 7, which means Tn equals 7n minus 1. Now guys, what you do is take that, and then what they mean by sigma notation is that it's a summation of all the terms in that pattern. And they said all the terms, first 20 terms, they want the summation of the first 20 terms, right? Now your sigma notation should be notated by the first 20 terms, right? And then you substitute the n, the first term, all the way to the 20th term. And then our term notation is given by 7n minus 1, right? This is a sigma notation of question 2.1.2, which said we deal with the first 20 terms. Now, if you want to check whether your answer is correct, your notation is correct, you simply substitute the n with the first term, the second term, and third term. Just substitute the first 3 terms and check whether you get the same value of those first 3 terms. Let's start with the first term. The first term is n 1 minus 7 times 1 minus 1, which in this case is 6. And then n equals to 2. Let's do that. It's 7 times 2 minus 1, which is 14 minus 1, should give you 13. And then going on to the third term, minus 1, 7 times 3, which is 21, minus 1 should give you 20. Now check whether these values are corresponding with the values of your first terms, of your first 3 terms. And then remember, let me just go back and check whether they correspond. Nope, it's not that one. Let me check this slide. Nope. Yes. Can you see the first term is 20, is 6, second one is 13, the third one is 20. So which proves our sigma notation to be correct. Our sigma notation should be correct. Our sigma notation should be correct. Let me just try to find where I put that slide. Our sigma notation should be correct. Our sigma notation is correct in this case. Alright, the next question is 2.2.1, and then it says given the geometric series x minus 2 close bracket plus x squared minus 4 close bracket plus x cubed minus plus 2x squared minus 4x minus 8, it says plus dot 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 dot, right? Now the question is, write the values of x for which the series converges. Now we've looked at different formulas when we started this lesson. Now this is a different one, right? Before you start there, they say to you it is a geometric series, meaning what you need to find there is your constant ratio. It's your constant ratio. You need to find your R, which is your constant ratio, right? Which is your constant ratio. Now, finding your constant ratio, what do we need to say now? The first term here, as you can see, is x minus 2. How do we get to the next term, right? We get to the next term by multiplying the first term by what? By x plus 2. And you do the same with the third term, and so on and so forth, right? You can even check it. X minus 2, x plus 2 should give you x squared minus 4, right? Now that we've determined our constant ratio, they say to you, remember, for a geometric series to be convergent, right, your constant ratio should be less than 1, but then greater than negative 1. And also, your constant ratio should not equal 0, right? And then we've just determined our constant ratio to be x plus 1. So in the space of x of R, you write x plus 2. X plus 2 should be less than 1. X plus 2 should be greater than negative 1. And then x plus 2 should not equal 0, right? But then remember, we are not looking for x plus 2. We want the values of x, meaning for me to, if I want to get rid of this 2 here, what I simply need to do is, say put minus 2, right? And then put minus 2 on either side of my inequality. It's minus 2, right? Meaning I'm left with minus 2 plus 2. I've got rid of the plus 2, meaning I'm left with x should be greater than 1 minus 2 is minus 1, right? And then minus 1 minus 2 is minus 3, right? You do the same here. It's minus 2, it's minus 2, meaning your final answer should say, so let me just make this clear, it's minus 1, right? Sorry, let me just write it properly. So after doing that, your x should be between minus 1 and minus a 3, right? And then your x, remember again here it's 0, should not equal negative 2, right? Those are your convergent values for x, right? Your x falls between negative 1 and negative 3, and then your x should not equal negative 2. Those are your convergent values for x. Alright, moving on to the next question. It says it's 2.2.2. It says if x equals negative 3 over 2, calculate the sum to infinity to the given series, to the given series, right? First thing that you should do, they say you must calculate the sum to infinity, right? We start by writing our equation of sum to infinity, which is sum to infinity equals a all over 1 minus r, right? Now we have determined that, remember, your a is what? Your a is your first term. Now in our equation, what is our first term? Our first term is x minus 2, and then our constant ratio, remember we said, is x plus 2. So let's write them down. Let's somewhat substitute. Our first term, like I said, is x minus 2 all over 1, and then our constant ratio is x plus 2. But then remember we have a negative here, meaning this sign is going to change to a negative, this will change to a negative, and then it's going to be x 1 minus x minus 2, right? Remember they said your x is negative 3 over 2, so you simply substitute negative 3 over 2 where you see your x, right? Let's do that, meaning we are going to have negative 3 over 2 minus 2 all over 1 minus, so it's negative. Remember now it's going to change to be a positive. Negative and a negative, it's a positive, so it's 3 over 2 minus the 2, right? So you can add these, and you do the same with your denominator, right? So let me just quickly add that on the side. So it's 3 over 2, remember it's minus and a minus, over 2 over 1, 2 over 2, so it's minus 3 minus 4 over 2, so it's negative 7 over 2 on top. It's negative 7 over 2. At the bottom you do the same, add your fractions. At the bottom you do the same. Let me just quickly take this out. At the bottom you do the same, so it's 1 plus 3 over 2 minus 2. The LCD, let me just write it so it can be clear. So it's 2 over 2 times 2 over 2, which in this case is 2 plus 3 minus 4 all over 2, which gives me a half. So it's all over a half, right? And then here you can just tip and times and say negative 7 over 2 times 2, which is 14. It's negative 14 over 2. Negative 14 over 2, meaning your sum to infinity should equal negative 7, right? The sum to infinity would give you negative 7. Alright, I hope you guys have been following and you taking notes. So let's move on to our next part, our next question. Looking at question 3, it says the first 4 terms of a quadratic let me just go back, of a quadratic number pattern is, so you're given the first 4 terms, which are negative 1, 2, 9 and 20, and what follows is the question, which says determine the general term of the quadratic number pattern. The quadratic number pattern. Now the keywords are, it's a what? Quadratic number pattern, right? Which equations apply here? The general term of a quadratic number pattern is Tn an squared plus bn plus c, right? Now they want you to write the general term, right? Now for you to be able to do that, you need your values for a, you need to know what b is, you need to know what c is, right? Now before we do that, let's write down our second difference. Our second difference in our pattern should be 2 minus 1, which is 3, and then 9 minus 2 is 7, and then 20 minus 9 is 11. They are not constant, meaning, remember again, they are not constant because we're dealing with a what? Quadratic number pattern, meaning you need to find your second difference. In this case, it's 7 minus 3, which is 4, and then 11 minus 7, which is 4, right? Alright, our general term is given as follows, right? As Tn equals an squared plus bn plus c, right? Now for us to do that, like I said, we need to determine our a, our b, and our c, right? Now what is our a in this case? That's the first thing that we need to determine. Our a is, in this general term, is the second difference divide by 2, right? We just did our second difference, which is 4, meaning 4 divided by 2, your A should equal 2. Right? Now we are left with B and C. Now it creates another scenario of simultaneous equation because we have two unknown variables, right? So can we solve them simultaneously? Of course we can try to solve them simultaneously, right? So we have determined A, which is 2. We still need to find B. We still need to find B, and we still need to find C, right? Let me write down my general term again, which is Tn equals an squared plus bn plus c, right? Now from here we can choose any term in order to determine those unknown variables. Let me choose the first term, right? Let me choose the first term. Let me choose the first term, which is Tn equals, remember we just found out our A, which is 2, and then first term squared plus B times 1, I'm just going to write it as B plus C, right? Our first term is what? It's -1. Let's double check. Our first term is negative. Our value for first term is -1. So here we are going to have -1 equals 1 squared is 1 times 2 is 2 plus B plus C. So here I'm going to isolate C, right? Make C subject of the formula, meaning I'm left with C equals, I take that to the other side, I take this to the other side, I'm left with -1, -2 is -3, and then the B goes to the other side, it becomes a negative, meaning I'm left with -B minus 3, right? So let's go ahead and choose another term. I'll simply go with the second term, which has a value of 2, So let's determine our T2, which is 2 into 2 squared plus 2B plus C, because term 2 is it's 2, right? So it's Bn. Let me just write it down so that you guys don't get confused. It's Bn. We substituted the 2, which gave me 2B. I hope you guys follow from there. Meaning, remember again, term 2, the value of term 2 is 2. Meaning we have 2 equals 2 squared is 4 times 2 is 8 plus 2B plus C, right? Now from now on you can just take the 8 to the other side, meaning you will have -6 equals 2B plus C, right? And I can go on and say this is my equation 1 and say this is my equation 2, right? Now what we do next is substitute equation 1 into equation 2, right? Meaning whenever we see a C in equation 2, we put -B minus 3, right? So let's go on and do that. This is our equation 2, which is -6 equals 2b minus, remember the c, minus b minus 3, right? So from now on we can say 2b minus b is b. We take the 3 to the other side, which will give me a negative 3. So your b is equals to negative 3. So from now on you can just simply substitute your b into either equation 1 or equation 2. So let's go ahead and say substitute the b in equation 1. Let's choose equation 1, meaning you will have c equals, whenever you see a b you put negative 3. Remember we still have that negative, so it's going to be negative 3, negative 3 minus 3, right? So meaning negative 3 is positive, and then minus 3 is 0. So your c equals 0. Your c equals 0, right? Now after determining your values for a, after getting your a, after getting your b, after getting your c, what do? You go back to your general term and substitute back those values, right? So let's do that. So I'm going to write down my general term again, which is Tn equals an squared plus bn plus c, and then we know our b is 2n squared plus, we know our a is 2, and then it's 2n squared plus our b is negative 6, meaning here it's going to be is it negative? Yes, it is negative. So meaning here we are going to have negative 6n, right? Let me just simplify this. Yes, negative 6n. We can leave it like that, right? Let me just go back and check. Our b is actually negative 3, sorry. So let's fix that. So our b is negative 3. Our b is negative 3. So it's 2n squared minus 3n. So that's your general term. That's your general term. Now going to the next question, 3.2. Now they say calculate the value of the 48th term of the quadratic number pattern, right? Now it's easy now for you to calculate that because you know your general term, and they want the value for the 48th term, right? Meaning number 48, right? So our general term, remember, we found a to be 2 into the the 48th term, right? Meaning your n here will be 48, sorry, close bracket, squared minus 3, and again we have 3 times 48, and then we can just punch this in our calculators and see what we get. 48 squared times 2, which is 4608, minus 3 minus 3 times 48, which is 144. We say 4608 minus 144, which is 4464. So the value, if you count from 1 all the way to the 48th term, that value on the 48th term, right, meaning T48, is 4464. That's your final answer. Quickly moving on to the next one, which is 3.3. Which is 3.3, which says show that the sum of the first difference of the quadratic pattern, the first difference of the quadratic pattern can be given by Sn equals to 2n squared plus n. Now let's go back and look at our first difference, right, in that quadratic pattern. Our first difference was given by 3, 7, and 11, right? Let me just double check. Should be given by 3, 7, 11. Anyway, you should be having that. Let me just not waste too much time. Alright, here it is. It's 3, 7, and 11, right? 3, 7, and 11, right? Now, we know our sum is given by Sn equals n over 2 close bracket 2a plus your n minus 1 close bracket your common difference, right? Now they say you must determine the what? Determine the sum of the first difference. Determine the sum of the first difference. Alright, remember our quadratic equation. If you're looking for the sum, it's given by this, right? Now we need to determine what our A is in the first difference. That's the key, first difference, right? And then we need to determine what our common difference is, right? So let's go on and write that down and say Sn equals n over 2, and then our first term should be given by 3, right? Meaning you will have 2 times a 3 plus n minus 1, close bracket, and then our common difference should be 4, right? Continuing here, we have n over 2, 2 times 3 is 6, and then let's distribute the 4 into the bracket. We will have 4n minus 4, right? So let me just quickly simplify this. We have 2n over 2, close bracket, negative 4 and the 6 should give you a 2, meaning we are left with 4n plus a 2. Now from here, you simply distribute the n over 2 into the bracket, meaning you will be left with n over 2 times 4n is the 2 will go into 4 twice, meaning you are left with 2n squared. Remember, you multiply the n's, right, which is 2n squared, and if you distribute n over 2 into these 2 over here, you are left with n over 2 times 2 should give you n. So we have proven that the sum of the first difference of the quadratic number can be written as 2n squared plus n. Alright, let's see if we have one last one. Now we have the last question in this question paper, which is the last question that deals with number patterns in this question paper is 3.4, and they say if the sum of the if the sum of the 69 first difference in question 3.3 equals 9,591, meaning the sum, right, S69 equals 9,591. Which term of the quadratic pattern has the value of 9,590, right? Now this is the sum of that term, right? Now they want you to find what is that term, right? What is that term? Now from our sum formula, we know that we're gonna say this sum, right, equals n over 2, close bracket, 2, and then we know our first term is 3 plus n minus 1. Our common difference is 4, right? And then we can simply say n over 2 times 6 plus 4n minus minus 4, which will be n over 2 into 2 plus 4n, right? Plus 4n. Now let's distribute again, meaning it will be n minus 2n squared equals 950 90, and then you can simply find the terms for n. So this is a big number, so after doing this, find the terms for n, and then that will give you the number of terms in that equation. The number of terms in that equation, that will give you the number of terms in that equation, right? All right, I think that concludes our number patterns for grade 12. Yeah, that concludes our number patterns for grade 12 based in question 2 and 3 of your question paper. I hope this was helpful to you guys, and we are going to continue with some more questions from the question papers, and keep on tuning in to this channel. If you are interested in it and you want to do well in your matric, you should be knowing how your question papers are set, and this will be very helpful to you guys going forward. And thank you for tuning in, and see you next time.